Helper T cells die.
What happens to infected cells when the HIV particles bud? Oh, okay.
Yes, and they leave, basically.
So the old helper T cells die?
Yes. If you read step 8, every baby virus takes some of the cell membrane with them. So if something is ripping out your skin, you eventually die. Right? Everyone watch Aliens? That's this. Right? So as they bud out, the cell begins to die off, weakens the membrane. That's how we kill. That's how your T cells kill, right? They punch holes in the cells. Well, the HIV does it by budding out.
Because when it's something else, the helper T cell, wait, never mind. Let me get confused.
So, what does it mean to be a retrovirus? Does anyone know what retronite means?
Reverse.
Reverse.
Reverse transcription.
Look at step number 4. It uses an enzyme. Remember biology 112? ACE was an enzyme. So it uses reverse transcriptase. That's what makes it a retrovirus. It uses this enzyme that goes in reverse. Because reverse just means backwards. So it's a backwards virus. That's all it means in biology land. So it runs backwards. How's this compared to other things?
Other pathogens, RNA get translated to protein, but this gets translated to DNA.
Very good. So not everything that kills you is a retrovirus. But some things that do kill you are retroviruses, just the biology of the pathogen. So you can have retroviruses, you can have non-retroviruses. The bad ones tend to be these. How long does it take for HIV to go from integration, step 5, to budding out, step 8, 9, 10?
10 steps.
Yes, but time frame.
Can it be a while? Like, doesn't it take
How long is a while?
Well, because doesn't
Years?
it, like, you can't even detect it right away.
Very good.
Like five years.
Trick is, nobody knows, because it varies by each person.
This is a few months to 12 years as well.
Months to years, decades.
You could be infected with a virus and not know for 10 years?
Yes.
Wow, that's insane.
Well, the problem is, right, it wasn't controlled. We don't know when you actually got infected. You're just claiming,
Yeah.
yeah, it was that night on the bar, but we don't know. But the average tends to be, we think months, but we don't know. So if you get your HIV test for your work at the hospital, how often are you supposed to go in and get tested?
Like every 6.
About 6 months. That's the logic here. It takes months, maybe 6 months, for us to figure out that it's there. So every 6 months, you would detect something if you're infected. But we don't know. Right? Yes?
So if it takes that long for this one first cell to become infected and stuff, does it just start growing like slowly, like really slowly in your body? So technically HIV is not very like aggressive, right?
Correct. Compared to the flu, it's an absolute win. HIV doesn't affect very quickly. It doesn't really do anything for months later. And that's how it wins. You know, flu just kills you today. And its hope is that by being airborne, you kill everybody else. HIV, to get to the next person, you have to be healthy enough to want to be with them. So I can't kill you now, and I can't kill you fast. So there's this weird evolutionary pathway. You can either be mean and quick, or slow and gentle. That's how you do it. But the problem is, yeah, you could have been infected at step 1, and we wouldn't see anything chemically until maybe 6 months later. Make sense? So what's the difference, number 5? What's the difference between HIV and AIDS?
HIV is a virus and AIDS is a syndrome.
It is. Very good. So HIV is simply saying you have a virus, step 1. So if you are HIV positive, you have step number 1. The virus is in your body. That's all that means. If you're HIV negative, there is no virus in your body. Right? AIDS are the symptoms. That's why it's called a syndrome. It's what the effect is. So the virus, HIV, is the cause. AIDS is essentially the effect.
But don't people live with HIV with tons of terrible stuff happening before they have full-blown AIDS?
Yes, because the symptoms build up over time. But AIDS is when you actually possess this syndrome of list of symptoms. So you get, there's AIDS, well there's HIV, then there's ARC, which is AIDS-related complex, and there's pre-AIDS, and there's AIDS, and there's, but yeah, you're just adding symptoms. You can be HIV positive and not yet have AIDS. But if you have AIDS, you were HIV positive. Make sense?
So can you be HIV positive and never get AIDS?
Yes, Magic Johnson keeps writing books about that.
You see that guy?
Yeah, so he got HIV, he claims, in 1980, what, 3? But he wrote his book around 88. And he supposedly is happy and healthy and making millions of dollars on TV. He has no symptoms.
Once you get AIDS, you die soon?
Yes.
As long as you keep AIDS at bay, you're okay.
That's the idea.
Yeah.
Yes.
Do you know where HIV came
Well, it depends. Are you a conspiracy theorist or not?
from? Sure.
Okay, so conspiracy theorist says Reagan invented it to kill gay people. That one still makes books, by the way. There is a conspiracy theory that it was on vaccinations. That people used to incubate vaccines using monkey serum. The logic is it was a monkey, and then it got into vaccines, we vaccinate people. That doesn't really explain why it evolved in Africa, which is where it came
But
from.
doesn't it come from monkeys?
Yes, there's a simian version. What humans don't get. What they believe happened was the simian one somehow changed enough to be human. The problem is, you can track HIV way back longer than before we named it. The earliest known death that they found is 1955 from a French sailor out of Senegal. So it's been around for a long time, it just never had a name. So one of the problems is, you died of everything else, it's hard to find virus.
I was reading about something how they thought the cause of, or how HIV came about is from people in Africa eating bushmeat,
Yes. So one argument is you eat an infected monkey.
and then you get it, yeah.
Yeah. One thought was getting bit by monkeys.
Everywhere else.
Yeah. So no one knows. We just know it's been around since the 50s. You probably got it from some monkey, but who knows, and I wasn't there. Right. Or Reagan did it. That's the other thing. Right? Alright, so number 6 is the key question that thou shalt really understand for your final. If you have AIDS, why do you get all this junk no one else catches?
Your immune system is
Very good. Let's go back to the picture. What's the job of helper T cells again? To command your army, right? So, if they're dying, my army doesn't get any orders. What do armies do without orders?
nothing.
Absolutely nothing. Because I don't do anything unless you tell me. So, if I don't have the generals, I don't get the order to attack, I just sit there and do nothing. Because you're not giving me the information of what to do. You're not telling me the specific response. Yes.
Is there, like a, it's so weird, but is there like, when they're giving people with HIV medication,
Yes.
do they give something that stimulates that to help with to help
Well,
direct
the
the
problem
T
with,
cells?
they tried that trick. The problem with that is if I make more helper T cells, the HIV can still infect those cells. So the current therapy is to stop the HIV part and not really speed up the helper T cell part. Because you'd have to turn on your bone marrow, which is kind of hard to do. Right? The idea is to stop the HIV. That would work if you could somehow make the HIV not keep up with it.
Well, because it's evolving inside your own body.
Right. So one of the tricks is more helper T cells just means more food for the HIV. Do again that one step. So that's the key idea is if I don't have helper T cells, I can't order my immune system. So number 7 then. If I want to check HIV in your body, what would I look at to see that HIV is there and doing bad things to you?
T count.
Helper T cell. Let's look at that picture. This is a picture showing HIV. So, CD4, the red line are the helper T cells. What are they doing? They're going down like a rock, right? Because as the HIV buds out, it keeps killing off your helper T cells. So they just crash. So a CD4 count or a helper T cell count is how they're measuring that. So the worse your virus, the faster this drops. Okay? Here's the problem. What's CD8? What's that blue line that's not going down at all? What is that?
Cytotoxic?
Those are the cytotoxic T cells. So you got to think about it. The HIV is not attacking the things that can kill. It attacks the ones that orders them to kill. So they don't kill anything. Your army's cleaning their guns while someone else invades.
Is that the CD8 that's lowering? Is that significant?
It lowers a little bit, but it basically stays relatively consistent.
That's the cytotoxic
Cytotoxic
cells?
Ts. So the assassins are fine. There's no one to tell them what to do.
They just can't go and kill the
They
cells.
just- No, they have to wait for an order. If you don't order me, I don't do anything. You don't do anything without our orders in the army. You can't take a dump without orders, son. Right? That's Wisconsin. Makes sense? So they would watch watch your CD4 count or helper T cell count to measure how bad HIV is doing. The worse the HIV, the less helper Ts.
So CD means helper Ts? Is that CD?
CD is the class of the co-receptors. They call them CD4 because there's a CD class 4 type.
Oh, okay.
Just chemistry.
How does this lead to cancer?
It doesn't directly. When they first noticed HIV, the sarcomas that came out of it were due to your immune system normally keeps fungal infections away, and some fungi cause tumors. So when you lost your immune system, the tumors popped up, and so they called it HTLV, which they thought was a cancer-causing virus. What they forgot, what they learned later is, well, no, it's just stopping your immune system from keeping the athlete's foot from killing you. So you die of athlete's foot, not because it's a cancer, because you can't kill it. So cancers can be killed off by T cells, but they have to be ordered what to do.
So there's some HIVs that you still keep your T cells not killing them that fast?
Yeah,
The people that
so
are like a little bit healthier?
let's say you just get infected. You
Yeah.
know, it takes several months for this to kick on. So your T cells will be nice and happy. Then when they begin to bud out, then it begins to drop. And if they slow the budding, then you could build, your bone marrow could catch up and build more. So you're racing between building them and killing them. That's what you're trying to do. So the more active the virus, the less. Okay. And there's actually a statistical number you're supposed to have that how many per unit liter at so much time, which I don't have in my head. You okay on that one? So, the worse the virus, the lower that one. So, let's do number 8. Let's read number 8. HIV cannot fix changes in its genetic material. That's what a retrovirus does. It cannot fix itself. So let's make a vaccine, shall we? Okay. How likely is that to work if the virus is always changing?
Not.
It's not, right? Why? How does a virus work? What does the virus require to work? So the host. What's it rely on?
Host's DNA.
DNA.
Changing it, reversing it?
Right. Remember, it doesn't rely on memory, right? So they have a vaccine is you've seen it once before, and then you remember it for the next time. If the virus is different every time, what do you remember? Nothing. So every time the virus infects you, it's a new infection. Whatever vaccine you had wouldn't have worked. You'd have to re-get infected and build new memory cells every time. So one of the problems of why you get a flu shot every year, or 4 times a year, and it doesn't work all the time, is flu does the same thing. Every time the flu produces, it's a new flu. You don't remember it. You have to start again every time. Yes?
Do you know about this new medication that they're telling people to take that can keep them from getting AIDS before they, or HIV before they have it?
Right.
How does that work?
It blocks one of the co-receptors, so HIV can't dock into the cell.
Oh, okay.
That's to my knowledge. But one of the problems kicks in, though, is eventually they think HIV will mutate enough to dock.
And then the medication will be worthless.
And then you gotta use the other stuff.
Oh, okay.
Just to show you this concept, let me show you my claims here. Where's my picture? Lost my, where's my HIV? I don't have HIV. Oh, there it is. Okay, I just had a picture of the claims. Okay, give me a second. I lost that picture. Hold that thought. There we go. So, not that you ever have to know this picture because you don't. This gives you the concept of why a vaccine for HIV is not so easy, same as the flu. Each color you see there is a different, quote, family of HIV, meaning a different genetic combination. So there's B, most common in the US, there's BF recombinant, which means a hybrid, there's D, there's whatever. So each of these colors represent a different shape of HIV, which means your memory cells will only remember the shape they saw. So if you got a vaccine for B type in the US, that's great. If you go to Brazil, it's worthless, because Brazil has a different shape. You'd have to then get infected, build memory cells over a 2 weeks period, and then you'd be vaccinated. Right? So you have to have a vaccine for each different country. That make it worse, people can be infected with multiple types. And multiple types are more predominant in different cities. So if I remember right, depending which end of Indonesia you're on, you'll actually end up with subtypes of different types. So you can be infected in one town and have a totally different strain if you go to the other town. So believe it or not, Seattle and LA have different HIVs. The vaccine would not work between the two cities.
So the recumbents wouldn't work like as an overall, like if you got a vaccine for the B.
So that one would kind of work here, and probably work with the S, but it wouldn't work with the GH and anything else. So you have to stay in your town, in your country,
Or just don't.
or just don't get it, right? Yeah.
So how does it mutate so much?
Ah, that's actually the retrovirus part. Worth a trivia. If you go to step 4, you remember your biology 112, that when you made more DNA, there's that error checking where the DNA made sure there wasn't a screw up?
Oh yeah, where it stops.
Right. This enzyme doesn't check for mistakes, so it just burns out copies as fast as it can. It never checks them. So every time the virus is replicating, it can end up with a mutation. And therefore, every child is mutated from the parent. That's why flu changes so much, it does the same thing. It doesn't check the baby. It's just trying to make as many babies as possible. It doesn't care if they're okay, because it's going to affect you anyway. It doesn't care.
So within our own bodies, we can have different versions?
Yes, you can.
So even if two people are both HIV positive, it doesn't mean that that it's like safe for them to have sex because they could be giving each other different types.
That's exactly how it works.
Wow.
So have they found a difference between, because sometimes it moves a lot faster, you develop AIDS a lot faster than other times. Have they seen a difference between the different
Yeah.
strands on which
So if I
moves
remember
more?
right, don't quote me, but I remember right, some of these letters have much higher virulence, meaning it can be faster and more likely to infect. Some of them have less ability to infect and less virulence. Yeah, so you can get infected with the same HIVs in different places. They're actually different strains, have very different pathways of how quickly they infect you, and yet be cross-infecting each other. Fantastic.
So why initially was it thought to be like a gay disease?
Because in the U.S., it was first seen in San Francisco in '84.
Wait, say that again?
It was first seen in San Francisco in '84 among gay men, so it got pigeonholed here as you have to be a gay guy to get it. The problem was they didn't swim over to Senegal. Everyone there is heterosexual and they all had it. But in the U.S., it got sort of, that's where they first found it, that's where they first named it. So it got kind of pigeonholed IV drug users and gay guys for it.
Oh, okay.
But in other countries, that's not the case. There's a big debate over why was it seen in San Francisco and nowhere else. And there's a huge, big controversy of why that was. So it's a combination of promiscuous sex, lots of drug use, blah, blah, but that wasn't the norm for the rest of the world.
So it's not like more transmitted.
It is easier to transmit through anal sex, which is predominantly homosexual in, but that's just the transmission. That doesn't explain. It's like being straight, you're protected. Anybody can get it. Just in the U.S., that happened to be the demographic.
Well, if you're monogamous, you can't, right? If your
Hopefully
partner
not. As long as
doesn't.
both you're monogamous, then there's
Okay.
no deal. That damn monogamy thing again. Damn, this America. Right?
How can HIV be transferred from mom to baby?
We don't know. We're not sure if it is. We'll get to that thought. What a thought. All right. Let's do this one here. We're going to flip the page over. We're going to do some hypothesis testing. So, if you wanted to stop HIV, if you were king or queen, what steps on here would be the best choice for stopping HIV? Pick a number.
1.
1 is a good choice. If you don't get exposed, then we don't have to worry about the other 10 steps, right? So let's make a list of the steps to stop HIV on the chart, and we'll see how we could do that. So steps to not write well. Prevent or stop HIV. So number 1 would be a very good choice. No exposure. Imagine that. If you don't get exposed, you don't have to worry about it. If only everyone understood that concept. Okay? So I don't have to worry about it. But let's pretend you don't believe that, and you want to risk your life. So name another step on here that possibly could be effective in some way to stop HIV.
Number
Find the
2.
receptor.
Number 2. Very good. If you could change your receptors, HIV could not find you, right? Your HIV couldn't find the helper T cells. Okay. Yeah, so receptors are due to what again? What determines your receptors? Your genes. This is called genetic immunity.
What is it like? One in every how many people have that?
We don't know because we'd have to expose you.
But there's some people who get exposed to HIV and then never get.
That's right, and they're this.
Oh. Okay.
Right.
That's so cool.
So all of you could be immune to HIV if you had a different shape.
But then you're still carrying it and you can still.
Exactly right. You got exposed. You have number 1. It never gets number 2, although you're sharing your number 1 back to everybody else who's not listening to this class. So there are people who will never get AIDS from HIV because the HIV can't find their cells.
Would you test positive?
You would test positive, but you would never actually advance to step 2 because you have HIV in your blood.
Yeah.
You'd never get more. Yes.
So that in itself could be some of the prevalence of people that don't progress as quickly
That's right.
because they never will.
They never will. In fact, worthless trivia, this is absolutely worthless cocktail trivia. They found several groups who are like this, don't become a prostitute thinking that makes you immune, it doesn't, right? But they found prostitutes who should have died, who don't get AIDS, and they found out they have this. So Zaire, Nigeria, Cambodia, what is it, Tanzania, there's no way. It turns out it actually raises their going rate with their clients because the clients realize, oh, you're never getting AIDS, you must be safer. The problem is that makes them more likely to pass off.
Wow.
That's true, they're not getting sicker, but they're still giving you number 1. Have a nice day. Welcome to the sex trade. Right. Let's pretend number 2 is not working for you. Where else could you prevent HIV? Number 4. What happens if you could stop that enzyme? Then the virus couldn't make DNA and therefore couldn't infect you.
Well, what happened in 3?
You can't stop 3.
You can't make
Once
a,
it gets
Nope.
onto the.
Once it binds, it's going to insert. There's no. And once you get to number 2, you have to then you can't stop 3 until you get to 4. You're sort of stuck. So let's do that. Let's stop enzyme. That's called AZT drugs. So if any of you have heard about Z-class or AZT, its job was to stop step 4. So you were exposed. It did find your shapes, but it can't convert. Therefore, it can't keep going. So you were exposed, but you're not going to have it reproduce. Make sense? Keep looking. Where's another spot you might be able to do something? Number 5.
number 5.
If you read number 5, there's also an enzyme there, integrase, that helps you merge. So if I stop the merging, that's actually an experimental drug now that they're trying to stop step 5. If you do convert, you can't insert. That's what they're trying to. That's right. So they're trying to stop step 5, so you can't get the DNA you made in step 4 to get into your DNA in step 5.
So could you kill all of your helper T cells and then have them
Yeah.
and remake all of them?
Mhm.
Would that get rid of the?
The problem is, what happens to you when you don't have any helper T cells?
You die.
You get infected and die.
Well, like if you were in a clean room or something?
That's the problem, yeah, we'd have to lock you in a bubble. They did this in Germany. They locked a guy in a bubble. They basically drained him. They took out all his blood and basically gave him a transfusion of someone else's blood, and he came out perfectly cured.
Wow.
The problem is, that doesn't mean we got all the HIV, that just means we got it out of your blood. So the question is, 10 more years from now, is he going to have HIV again from the HIV we didn't catch the first time? Plus, it's not like an oil change, just $20, drain somebody
my
and
gosh.
go back. It's a little hard to do. Okay, let's keep going. Name another step where you possibly could stop HIV. Go down to about number 8.
8.
All right, so that whole 8, 9, and 10 window, if you read that, there's an enzyme to make the virus grow up. So we're going to stop the enzyme again. This is called your cocktail drugs, or your protease cocktail. Or protease inhibitor cocktail, a protease antagonistic. So that's trying to stop the viruses from maturing. So you were infected, it did reproduce, but they can't go again. They can't reproduce more. So if you know someone with HIV or AIDS, chances are they're taking the Z drugs to step 4. They're probably taking the cocktail drugs for 8, 9, 10, and someone's telling them, please don't do number 1. That way you can stop it from going in, stop it from coming out, and hopefully not get it again. That's the concept. Number one's always the better choice.
No exposure, they tell people with HIV to not have sex?
Well, yeah, we can tell people that all day long, they don't listen,
But
but
is
yeah.
that what they're told, don't have sex anymore?
Or safe sex. No one listens to that.
They don't even say it's okay if you use condoms?
No, I mean, it is okay, it's less okay than not, right? Because then you get the problem, well, then you get people saying, well, if I use a condom only part of the time, it's
Oh my
okay, right? Or he's using a condom, I'm safe, you get that thing, or, gee, I'll use the condom only at the end, you get the negotiating stuff. Right? Well, yeah, you can do lots of things that don't require a condom, they'll give you this, right? So, but that whole abstinence monogamy thing is just so old-fashioned. So, let's do some hypotheses. You and your team are gonna do number 2, where do you think HIV is the worst in terms of infection rate? And how do you think people catch it there? And then we got some gee-whizzy behaviors that you're gonna rank as being how risky they are for HIV transmission, given your understanding of this virus. I'm going to give you and your team a few minutes to take wild guesses, hypothesis meaning take a guess. And we'll talk about
Educated
these
guess.
It's high. Domestic injury.